Okay, so welcome back to the second video in the Mac OS or Mac operating system kind of auxiliary set of videos for C# application development. What we're going to do right now is we're going to do a really quick kind of brief introduction to MongoDB. And the reason we want to look at MongoDB is because if you have only access to a Mac machine, you're not going to be able to run SSMS or Microsoft SQL Server. And because you can't run those, you're not going to be able to use Entity Framework natively. So the alternative to this video is to either create your own sort of file system based storage or persistence, or to use dual boot or boot camp or something like that to have a Windows machine run side by side with your native machine so that you can actually go through the ORM videos for Entity Framework. So there's a little bit of setup required to use MongoDB, and so what I'll do is in the Canvas page, I will put a link to exactly the steps that you need to walk through, but really quickly I'll kind of recap them. What I did is I used Homebrew, and first I essentially just tapped the MongoDB tap. And then I used brew install to install MongoDB Community, which is the free version of MongoDB. And then I started the MongoDB database service by issuing the services start command on MongoDB Community. And so after that, you can actually enter your instance by using the command mongo. And there you can sort of issue whatever MongoDB commands you'd like. I'll also put a reference to MongoDB keywords and common commands so that you're not kind of lost with no direction at all. The more important thing is how do I actually use MongoDB from C#. So I'm going to kind of orient you in the solution that we were talking about in the previous video, and also where this would go inside of the projects that you might have seen in the PC version of the videos. So basically what this is a simple console application that goes through the process of finding or creating a database, finding or creating a collection, adding things to that collection, deleting things from that collection, and updating documents in that collection. So this is essentially the exact same thing that we did with the really brief introduction to Transact SQL. So from that perspective, we're doing the exact same kind of CRUD operations that you have to do for the fourth assignment. From a where does this go in my solution perspective, this would all be information or data, or not data, but code that you would want to put on the server side, either directly in an EC, or you would want to build a helper method that the EC would easily be able to call and interact with your MongoDB database. So to connect to the MongoDB instance, you have this default location on your device. This is exactly the same as the kind of default connection string that we talked about for running a local instance of SQL Server. And so here, this DB client is doing exactly the thing that SQL client was doing when we tried to establish a connection, but it's also the same thing that our database or DB context for Entity Framework is doing when we pass the base class a connection string. So this DB client object is now going to act essentially as an ORM. The main difference being that when we were looking at T-SQL or Microsoft SQL tables, we were looking at a relational structure that we needed to port over to an object-oriented structure so that we could actually use it in our server-side code. Instead, what we're looking at here is an unstructured database. And in these collections, so a collection is essentially just a table, you have a whole bunch of documents. Each of those documents is essentially just JSON. And so if you see here, there are tons of references to what are called BSIN or BISIN documents. what these things are is binary JSON. So these act exactly the same way as the JSON documents that we've been dealing with on the client side of things in the SPA video, and on the server side of things when we were actually trying to parse requests into strongly typed entities. But here, the difference is that the length of a field inside of a Bison document is known because there is an indicator for each of those fields. And arrays have explicit indices referenced in the representation of the document. You don't have to count through them. Outside of that, the representation of Bison and JSON are essentially the same. And on a Bison document, you have this handy dandy .toJSON method. Probably on the wrong thing. If you have one of these documents, you can always do .toJSON, and it will give you the string version of that JSON file that you can then pass to Newtonsoft like we've done in the past, and you will get the ability to deserialize that into a strongly typed class, or do any of the other stuff that we've done in the other videos with a JSON string. So in some ways, MongoDB cuts out the middleman. You don't necessarily have to have ORM because there is no relational structure to map from. The main difference is that the way that Bison documents are stored is slightly faster to access than JSON, and that's kind of an obvious architectural design decision on the part of MongoDB. You want your database to be fast as possible in terms of access. So if we just really kind of quickly go through all of the CRUD operations. So one of the things that is fundamentally different between MongoDB and SQL, be it MySQL or PostgreSQL or Microsoft SQL, those relational structures typically require you to create a table before you use it. What happens in MongoDB is you request a database or you request a collection, in either case. And if the collection or the database does not exist, you are given that database or that collection in an empty state. So if you do not currently have a database called abet_db, you will be given a blank database named abet_db. When you start adding things to that database, you will actually start seeing the documents when you start querying the actual database. Same thing goes for collections. So the first time you add a collection to a database, you are adding a collection to an empty database. The first time you add a document to an empty collection, you are creating that collection by virtue of giving it a document. One of the things that is also different from kind of the T-SQL where clause perspective is that where clauses are really considered more of a filter situation than just a where clause. And so what you will find throughout is we'll be using either an explicit filter from the builders class, or we will be asserting a partial document as a filter. If you do not pass a filter to an operation like delete, what will end up happening is you will delete all of the documents in the collection. So here, this is effectively a line of code that is resetting my document collection inside of ABET database, so that if I have anything in semesters, I delete it prior to establishing what I want to be in my list of semesters. The next operation is insert one. So this is if I want to just create a brand new semester and I want to pass that into the list of semesters. So here we see that semesters is just a reference to the set of all semesters, or the collection of all semesters from my abet_db MongoDB database. And here, what I'm doing is I am using the insert one method on that list or that reference to put a brand new Bison document that represents a new semester. And so here I'm giving it an attribute called ID with a value of 1. Here I'm giving it an attribute name with a value of fall 2019. I can also do the exact same thing, but for many at the same time. So here I'm inserting only one document. Here I'm actually passing a brand new list of Bison documents. And here I'm just using the explicit declarative sort of syntax for creating a new series of Bison documents inside of a list of Bison documents. So there are slight differences between filter and find. So here, what we're doing is we're using the find syntax to essentially impose a filter or create a where clause and apply it to our collection of semesters. And so again, we don't supply any values in the Bison document in the find clause. And so because the find clause is not past a filter, it gives me everything. And so when I hit this console.writeLine, it will actually give me back this whole list. So ID 1, 2, 3, and 4, and each of these names in a list. Now, if I want to delete one of these items, I can call the delete1 method, and I can pass that a filter that tells me which one I want to delete. So there are two ways that you can provide a filter to one of these methods. The first one is providing an explicit potentially partial document. So here I'm looking for any documents that have ID value 1, and it will delete the first one of those that it finds. Alternatively, and so here we're just iterating through and showing that we actually deleted ID 1 document. The alternative way of applying a filter is to actually use what's called the builders class, and that builders class exposes a filter, and that filter allows you to do things like equals or less than or greater than or less than or greater than or less than or equal to, so on and so forth. So this is an explicit filter. This is an explicit document that is implicitly casted to a filter when it's passed into this method. This is a probably safer way of living your life because you can not only express much more robust kind of Boolean logic, but you can also ensure that the filter is applied. You can check that filter and then actually apply it somewhere. So here, we don't necessarily know what's going to happen, what the result of that filter is going to be. Here, we can actually apply the filter, check to make sure that we get what we want, and then apply it to the collection. So we've talked a little bit about insert and delete. The primary one that we need to talk about now is update, which is an extremely kind of prominent use case. And so here what we have is an example of not only update, but also how to use the builder's filter methods instead of providing a Bison document as a filter. So here what I'm doing is I'm setting up a filter, and that filter is going to apply to only the document that has ID equal to 2. Then I'm also setting up an update command, and that update command is going to set the value of the attribute name to my new semester. So this is a filter, this is an update command. What is happening next is I'm actually applying that update command to that filter on the semester's collection. So update 1 allows me to update the first item in the collection that is returned by this filter and apply this specific update. So what will happen now is we'll go to the document with ID equal to 2, and it will change the name from Spring 2020 to my new semester. And so that is kind of what is happening in this file. I'll put this file up on Canvas so you can take a look at it. But essentially what you would do is all of the kind of EC stuff that you see using Entity Framework, so DB dot some name of models or the DB set stuff, you would replace that logic with an equivalent version of that using one of these methods. So this should get you all of the different things that you need in order to make your life easier. The one thing that it does not handle is identity identity synchronization. So for this particular project, you don't necessarily have to deal with ID synchronization. It's really a concern for applications that are going to be used concurrently by multiple users. However, if you are interested in doing so, an easy way to do it in MongoDB is to have a single collection that is a collection of keys. That collection would have attributes that correspond to each of the collection names. So in this case, it would have one for semesters, it would have one for classes, it would have one for courses. And then the value of that attribute would be the last key that was given to a person that tried to make an insert. And so what will happen is that that kind of implementation will impose the exact same kind of counting logic that is happening in the database using the entity framework approach. And you will be assured that if a person requests an ID, the same ID will not be granted twice. Essentially, when that ID is given to someone, a counter will update the attribute for that collection in the keys collection of your database, and then you don't have to worry about ID collisions anymore. And you can make sure that when you go and you apply a filter for a specific ID, you're going to know exactly what you're going to get back out of the collection. So one piece of additional advice is if you work in industry and you do a significant amount of work in entity framework or a familiar or a similar ORM, what will ultimately happen is you'll very likely get into a situation where you need to synchronize models that become increasingly large. So if you imagine having a class that has a full roster for a course on it, and you're trying to pull that across from a Canvas server or something to a web front end, you would not necessarily want to pull that entire list every time you wanted to update the name of the class. You would really just want to send updates on the specific attributes that are being changed, so you don't have to send the entire model back to the server. This reduces the chattiness of your app quite a bit, and it also increases the number of users that can concurrently use the service, because it isn't spending so much time decompressing and then recompressing these giant web requests. So an approach to handle that is called updates or management by change set. So this is a thing that you can go out and do some reading on. Basically, the idea is if you have the ID of an entity and you have a list of properties and values that the property should be set to now, you can always retrieve the value in the database server side and then apply the list of changes without sending the entire model from the client to the server. There's clearly still some chattiness between the database and the web server, but you can cut down the chattiness between the client and the web server. And usually, especially if you have a cloud-hosted environment, the bandwidth between your database server and your web server will be much, much better than the bandwidth between potentially like a residential Wi-Fi network and your cloud-based web service or web server. So this is kind of an architectural note at the end. This is this sort of update set specific field, specific value is very, very similar to the concept of change sets, which has very successfully been applied to situations where you have to manage very large sets of data. And it's something to certainly be aware of, particularly if you're not working in a RESTful situation, you're using something like WCF. It's very, very important that you try to minimize the amount of data that is going across the wire from the client to the server or from the server to the client. So with that, I will stop rambling. But if you have any questions at all about MongoDB, or if you have any questions about sort of why this is relevant or where this should go in your application, if you should choose to use MongoDB, please send me an email. I'm happy to help in any way. And I really appreciate you watching this video. Thanks so much.